Hi class, I'm getting a lot of emails now. I guess people have started studying. To be quick about the replies, I'm just making quick videos, and that way you can all benefit from my answers, if my answers are good, I suppose. So here's an email I just got, and I thought I'd include that in this video because I received one, or maybe it was two other ones that were similar that I had replied to directly. So here's the email. Dear Professor, studying the cash lecture, and I'm confused about what the three types of cash are. Are the three types of cash L1, L2, and L3, or are they direct, fully associative, and set associative? I originally thought it was L1, L2, or 3, but one of your comments, blah, 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 blah. Please clarify this. It's definitely direct, fully associative, and set associative. You have to know what those three are and how they work. If not, you're not going to have a good time on the exam. Here's another email I received earlier today. Hello, Professor. I was going over the slides you posted under exam materials, and I'm a bit confused. For example, the interrupts for X86 only has one slide. Should we go over the X86 slide deck and then just focus on that one slide? Or is it because we were tested on the other things, we're not likely getting tested on them again? Well, that's part of it. And part of it is I can barely stand X86. And I think you guys are pretty sick of it as well. So let's focus on ARM. And the only X86 stuff you should know is what's currently in that posted shortened deck. Don't worry about other stuff. So hopefully that answers that question. Another question, even earlier today. Hello, sir. I hope you all is well. I am well, thank you. I was going through the annotated slides on CUlearn, and I noticed that the slides about glitches and hazards are still in the PDF. I recall that in class you said that we don't need to know it, do we? It'd be good to know. If I ask it, it's going to be very superficial, maybe a true or false or multiple choice type question. Just skim through it. Don't study it in great detail. There'll be nothing like calculations or anything like that. Just know the gist of it. Also, there were some slides that were vague, as I don't recall taking it during the semester. I even looked through the slides that were posted during the semester on CUlearn, and I could not find them. These slides are slide 83 to slide 104. Can you please clarify whether we need to know them or not? What the heck is this? So let's take a look. So it's these beautiful slides I made just for you guys. Timing effects, skew, and jitter. They're so nice. How could you not want to know them? Let's see. I guess you guys have enough to study. There. Happy now? Don't worry about those. Actually, you said up to 104. You have to know this stuff. Just the ones I crossed out. Timing effects, skew, and jitter. Don't worry about those. Here's an email. I was going through the slides and I noticed that you had marked up the slides on Kyle and toolchains cross compilers, and I was wondering what would be expected from that section. Something like the questions from the lab. Yeah, something like the questions from the lab, or just generally what's going on with the toolchain. What different libraries can you use? What are the benefits of the various libraries? And so on. General questions. The lab questions I'm planning on asking you are very general. Nothing specific. I'm not going to ask you how to set a specific register, for example, or to write a line of C code to do register settings. Don't worry about that stuff. So these are high-level questions. Okay, here's a good one to know. Hello, sir. I was just going over the interrupt notes for the Cortex processor, and I remembered a while ago in class that you mentioned the ISR for ARM will put bogus return values into the link register when returning from an interrupt. The processor would see this bad value and know what to do. I do not see this anywhere in the notes slides, but I'm wondering how the processor could ever know where to return to if you put a bad value into the link register. Once the ISR is complete and completed, the LR will go to the PC and bam, we are in a bad place where the processor knows what to do. I'm wondering if the real LR is maybe put onto the stack and comes back later. So that stuff's in the slides. Let me show you where it is. So look around slide 138 in the PDF, page 138 I should say. I said, do know this three-step process. So I told you guys not to memorize lengthy stepwise sequences, but this is a good one to know. It's only 3 steps. Of course, there are sub-steps. So within these 3 steps, in the second step, there's a process of stacking. That's when you want to do an exception handling event. So the stacking, if you look, throws a bunch of things onto the stack, including the second thing thrown on the stack is the program counter. Now going back to your email, in your second paragraph, you're saying once the ISR is complete, the link register will go to the PC and bam, we are in a bad place where the processor knows what to do. So yeah, it knows what to do. It knows to pop things off the stack, and one of the things is going to pop off the stack is the correct program counter, so it can get back from the ISR to the main code that was originally running. So read through those slides, 3 or 4 pages of slides. Make sure you understand how that whole process works from beginning to end. That's a huge hint for you guys.